Hello students, in this video I would like to discuss about insertion sort and its analysis. So insertion sort proceeds by inserting each element at proper place in sorted list. We will consider our list to be divided into two parts, sorted part and unsorted part. Initially, sorted part contains only first element of the list. In each pass, the first element from the unsorted part is taken and insert into the sorted part at the appropriate place. If there are n elements in the list, then after n minus 1 passes, the unsorted part disappears and whole list becomes sorted. So it's a simple way of inserting elements. So here I have an array where the elements are unsorted. The first thing is I will divide this array into two parts, sorted part and unsorted part. Initially I will consider one element in the sorted part and remaining elements in the unsorted part. I will take the first element from the unsorted list and that element will be inserted to appropriate place in the sorted list. I will explain insertion sort with the help of an example. So here I have an input of 6 elements which is an unsorted array. Initially I will consider this 33 in sorted part and remaining elements in unsorted part. What I do here is, in first pass I will take 22 and I will insert in the appropriate place. So I will insert 22 before 33. So now 23 and 33 are in sorted list. Next what I will do, the remaining part is the unsorted part. I will take the first element, that is 66, and that will be inserted in the appropriate place. Here 66 will come after 33. So 66 will retain its place. So 22, 33, 66. These three are in sorted part. Similarly, I will take 11, that is the first element from the unsorted list, and it will be inserted here before 22. So the logic is very simple. Take the first element from the unsorted part and insert that element in appropriate place in the sorted list. So go through the remaining passes. Here one more point. Here in the input I have 6 elements, but I have only 5 passes. So if there are n elements in the list, then after n minus 1 passes, the unsorted part disappears. That means the entire array becomes sorted. So this is the method behind insertion sort. Then I will move to algorithm. So here is the pseudocode for insertion sort. The input will be a sequence of data in a of 1 to a of n. That means the input will be an array A whose index value will be starting from 1 to n. Here I have a for loop here. It will iterate from j equal to 2 to length of a. All remaining statements are within that for loop. That's why some indent is given. And also remember this line number 5 and 6 is within this while loop. And line number 7 is actually outside this while loop but inside this for loop. So I will explain the algorithm with the help of an example. So the j value will be iterating from 2 to length of a. So initial value of j will be 2. Key equal to a of j. That means key is a of 2. What is a of 2? It is 22. Always remember, key will be the first element in unsorted part. Then I equal to j minus 1. J is 2, so j minus 1 is 1, so I equal to 1. While I greater than 0 and a of I greater than key. I is greater than 0 since I is 1. That is a of I. A of 1 is 33. 33 is greater than 22. So this statement is true. So a of I plus 1 equal to a of I. So what's the meaning of this statement? A of I is stored in a of I plus 1. A of 1 is stored in a of 2. That is a of 1, 33. That 33 is stored in a of 2. I equal to I minus 1. So I value becomes 0. Then again this condition is set. This I greater than 0 is false. So it will not execute these two statements again. Then it will execute line number 7. It's a of I plus 1. A of I plus 1 is a of 1. In place of a of 1 I am storing key. So 22 will be stored. This is how I got pass 1. Again this for loop will repeat. What's the value of j now? j becomes 3, key becomes a of 3, a of 3 is 66, I equal to j minus 1, that is 2. So 2 is greater than 0. What is a of I? A of I is a of 2. 33 is greater than 66 is false. So this for loop doesn't execute. These two statements will not execute. So in place of ai plus 1, that is in place of 3, I am storing key. So in third position 66 is stored. That means that position is retained. One more iteration. Next what happens? J value becomes 4. At that time key will be a of 4, that is 11, and I will be 3. Again this condition will be checked. I is greater than 0, 3 is greater than 0. What is a of 3? A of 3 is 66. 66 is greater than key. So a of I plus, in place of a of I plus 1, I am storing a of I. So in place of a of 4, I am storing a of 3. So this 66 is stored here. That means I am just shifting this one. So this statement needs to shift the element right. 66 is stored here. Then I equal to I minus 1. I minus 1 is 2. Again this condition will be checked. 2 is greater than 0. So what is a of I? 33. 33 is greater than 11. So that 33 will be also shifted. So 33 is stored here. This 33 is stored in place of 66. So 33 comes here. Then I equal to I minus 1. I value becomes 1. While I greater than 0 is true. What is a of I? A of I is 22. 22 is greater than 11. So again that 22 will be shifted. Then I equal to I minus 1. I becomes 0. Then this condition will be false. Then this statement will execute. What is a of I plus 1? A of I plus 1 is a of 1. In place of a of 1, I am storing 11. So you just look these two steps. 11 is compared with 66. 66 is larger, so it is shifted. Then, so 66 comes here. 11 is compared to 33. 33 is larger, so this is shifted to right side, so it will come here. 11 is compared with 22. 22 is greater, that is shifted here. So in the first position I am storing 11 because I have stored 11 in key. So key value will be stored here. So similarly remaining passes will execute, and then I will get a sorted error. Next is analysis of insertion sort. So here I have a for loop. It will execute from j equal to 2 to length of a. So length of a is, if n elements, length of a is n. 2 to n means n minus 1 steps plus for the false condition. So n minus 1 plus 1 is n. So this for loop will execute for n times. So these two statements execute for n minus 1 times. And we will come to this while loop. This one is very important. So the list is a reverse sorted list. So just consider this list. So initially the I value will be 1. So I greater than 0. Here is I greater than 0, and here I have a I minus 1. So in reverse sorted list, this will execute for I equal to 1 only. After that it suddenly becomes 0. So this condition will be true for only one instant. When I equal to 1 only, this will be true. It will run for true condition once, and the next case itself it will be false. So that's why in the first iteration it will execute a maximum of 2. So in the next case what happens? J value will be 3. So in that case this I will be 2, and it will work for I equal to 2 and I equal to 1. So it will work for 3. In two cases it will be true, in the last case it becomes false. So similarly next it is 4 and up to n. And here it will be these two statements take the same cost, 1 plus 2 plus 3. Because during the first iteration only one instant this condition is true. Because I greater than 0. I is equal to 1 only, this will be true. So that's why it will execute only one time. When next case initial value of I will be 2. So for I value 2 and 1 it will execute. So that's why here it is 2 times this one will execute. So this one is for reverse order condition. We will work out some examples so then it will be more clear. So this one is inside this for loop, so it will execute n minus 1 times. So you just take the sum. Anyway, somehow you will get n square of the higher order term. So the complexity is O of n square. Okay, next come to the sorted list. So here what happens, you just look at this condition, a of I greater than key. In sorted list what happens, what is initially a of I? A of I is 11. I am comparing 11 greater than key. At that time key will be 22. Because initially only one element in the sorted list. We will take the first element in the unsorted list as key. That I am comparing whether it is a of 1 is greater than key. Anyway it will be false. So it will execute only once in the first iteration. Again next time what happens, 11 and 22 are the sorted part. Key will be 33. 33 will be compared with 22. In that case itself the while loop will be false. So it will also execute n minus 1 times. So in sorted condition this loop is always false. The condition inside this loop is always false. So these two statements will not execute. So this is inside this for loop, so it will execute n minus 1 times. So here the higher order term is only n, so the complexity is order of n. So best case of insertion sort is O of n and worst case is O of n square. That's all about insertion sort. Thank you.